Hello everyone and happy holidays. Okay, like I was mentioning on the forum, I have all the 8 coils here. And I'm measuring the resistance in it with the Hioki meter, resistance meter. And yeah, it's somewhere because I've been playing with it, so they are kind of warm. 56.6 volts, ohms. I'm sorry, resistance meter, ohms. So and I had set up the PSU power supply unit at 56.2, which is more or less that. So I get an amp return on the current. So I'm going to remove the resistance meter, and in order to hook power to the coil, to the full group, because they're connected in series. So I'm hooking positive on this side, and negative at the other at the end of it. So, but I have on purpose I have placed them separated by a gap, so you see what happens when I add the power. Okay, so you watch, and they come together as one unit. It happens because it is a chain, an attraction chain, and each coil is a north south north south north south north south, and south north south north south north, and so they get all as one field, one main field with a bigger north here and a bigger south here, and a central block wall on the center. The point is that I wanted to take measurements now of the. Now it's the same as you get 8 magnets and you join them together and you got one magnet, longer magnet. If you get 8 cubes or 8 cylinders, you join them together, you got an elongated cylinder, one field. The same thing here. Okay, so now I am going to show on the probe. Yeah, I'm going to set it to Gauss, and yeah, I have it inside here. So one thing about this probe, about this meter here, and this is why the reason why the reading came wrong on the Campen testing done by Josh. This probe you can replace. It doesn't come with two probes, just one, and it's the transverse probe. The other one is the axial probe. It doesn't come with it. You have to order it separate. But this probe, it gets the angle, and it's got a Hall sensor at the very tip of it. Okay, and this is the cap. Okay, for both probes. So we had to remove the cap, and this cap, it shows the Hall sensor right there at the end, the tip, the black little chip, and it has a back part where the soldering is. And I mark it with red dot because the way this thing reads, you have to face the pole with this side of the probe. If you face it with this side, it'll give you the opposite pole. Simple as that. Plus, it takes its time to actually read it. Let me test. Let me move this to the center and take this probe right here with the mark that I did with a little tape, and I'm gonna put it facing here. I get a north. I got 80 Gauss. Okay, so if I move it around here, I'll be capturing the south part of the coil. Okay, of this coil. If I go here, I get the north, the sum of all the coils. So if I go here, I get a higher reading Okay, and if I go here, I get even higher. So if I go here, I get 126. Here it's 142. And it's always good to have handy this tool right here, this pen. It tells me exactly this is a dead north, okay, and here is a dead south. Here there's nothing because of the block wall. So if we're getting on this the wrong reading, we know we have the probe inverted. Okay, so this is supposed to be the way I did the mark, with the back of the probe facing the pole. And I come here and I have to, okay, I have to turn around the probe and put it right here. And then I get a reading right here, south, on the back of it. Okay, now if I go away from the probe, start decreasing, which is great because this is what I was talking before. This is the gradient. Okay, right there is 0, almost 0. So this is great. And here it's the same way. Okay, I get it closer, I get a higher reading, I go away, and because of the steel, get a higher reading here. But if I move it all the way over here, okay, and I start reading, you see right here the decrease of the north. Right here is higher, and as I move it back, it starts decreasing until I get to the steel. Now here it amplifies. Okay, and I don't know why it amplifies as south, because it's supposed to be north in here. It's a north. So it's a probe problem issue. Right here is reading south, and it's supposed to be a north. Now here is a north at 113, 140, and here it's a south at 50, 36. If I get it here on the steel, it goes at 170. And if I go on the back part, that's 245 on the back part, on the back plate, which is great. Here is 164. Now if I approach it here and I get the reading here, I go 260 here. So it increased right here, and it decreased right here to 130. And that's what we want to do. We want to measure the let me turn it on. It got off again. It's got an automatic turn off time. So you have to turn it around till you get the south reading, but what we're looking here is field strength. So, and it's great. So it moved from instead of Gauss, it went to micro Tesla. So anyways, so the field is here. I'm getting a high reading here. I'm getting a high reading here. I don't know why it's giving me south here, but it's the wrong reading on the meter. So here it's south, like 63. And as I move it backwards, it starts decreasing. And this is the gradient that we were looking for. So the fluctuation is based on that. So anyways, this is wanted to show you that the reading, and as well as this meter, how to operate it. Remember to remove the cap and how to measure the fields. Do some testing with this tool. It helps you a lot to make sure that you're measuring the right with the probe. Also, basically this is gonna give us strength. forget that much the polarity. It is too sensible, and I noticed that it swaps on each coil, which is not supposed to be. Anyways, I had the scope just connected to the output coil to see the fluctuations it makes when I move the field, and I get some fluctuations, so which is good. So now I'm disconnecting, and thanks for watching, guys. Have a happy holidays.